Hello everyone, welcome to the day 2 of Android Study Jams. So the agenda for today is we'll be working on a project in Android Studio. We'll be creating a new project and building an existing project. So without wasting any time, I would like to hand it over to Karthik. Karthik, over to you.
Yes, thank you, Monica. So, hello everyone, welcome to the Android Study Jam session 2. So, I can see we only have one additional participant. Uh, did you attend yesterday's session? Can you please either respond in the chat or unmute?
No, actually, just this is my first day.
Okay. So welcome. So today we'll be going over how to create working with projects in Android Studio, creating a new project as well as working with an existing project. So I'll be looking forward to your questions and your feedback after the session, so that I can improve. So let us start. So I'll share my screen and um, let me see. Yes. So this I hope you can see my screen right now. This is the Android Studio start screen. This is what you will see if you start up Android Studio after setting it up. Yesterday we went over the SDK configuration and the environment configuration, so I won't be covering it today. We will straight away start with how to create a new project. On the left side, you can see that there are I can see the projects that I have already created before in the past or opened, and we'll get into that a little later on in the session. But for now, let us focus on the create new project section. So when I click this button, um, you will see that I have several options. These options they tell me they allow me to configure the project as required. So Android Studio comes with a lot of pre-built templates, with a lot of inbuilt templates, and depending on the use case, you will choose one of these templates just so you have it will put the code, it will make the folder structure, create some sample files to that according to the recommended best practices according to the standard configuration, so that your project follows these best practices. I'll go over these one by one. By far, the most common type of projects are phone and tablet projects, smartphone projects. You also have options for Wear OS, Android TV, and automotive. Android Things is a deprecated API. It was a project by Google to similar to Alexa actions. So it was an extension to Google, the Google Voice Assistant, and it was meant to control different parts of like smart houses and also speakers and connect with the Android ecosystem in general. Right now, the project is no longer supported. It has already started shutting down as of 5th of January 2021. So this will most likely go away in the next few updates. So we'll not be focusing on this. But yes, by far the most common form of projects are phone and tablet apps. In that, you have several options. No activity is if you want to build a background service. For example, you have Google Sync, you have push notifications. There are certain background apps that run background services that you can install. If you want to do that, if you do not want to show a GUI as the primary part of your app, then you will choose no activity. Basic activity is, as the name implies, a basic activity. It just has a plain sample screen with the back button, the options button, the three dot menu in the top right, and a floating action button. The floating action button is a common part of material design, and you will notice this as you work with Android, that material design elements are heavily featured. Now, then you have bottom navigation action. Now, bottom navigation action is the modern way of doing things. So before, in older apps, you might have noticed there was a tabbed activity. YouTube had a very prominent set of three tabs in the beginning. You had your homepage, you had trending, and you had subscriptions. Now they have switched up the layout, but these tabbed activities used to be very common before when phones were smaller and you could fit them in one hand. Nowadays, since the phones are becoming larger, tablets are becoming larger, the preference is to put the UI controls and navigation controls towards the bottom of the screen, because that is where you hold your phone. You don't The user does not have to reach to the top to toggle something. That is why bottom navigation activities are becoming more and more common. Most Google apps, most first party Google apps like alarms, clock, YouTube, YouTube Music, Play Store, they are switching to bottom navigation activities gradually. Empty activity is an activity without any of the additional buttons. It is just an activity. If you want to build everything from scratch, you would choose this. You have now full screen activity. Full screen activity is where you have an option of hiding the status bar. You can see that there is a like short description for all of these when you hover over them. It will hide the status bar as well as the navigation buttons, the soft navigation buttons, if they are present. So, for example, if you are building a video viewing app, or if your app has a section to play content, full screen content, you will choose this. Now, this is a little different. This is not like a project per se, but this is an activity wherein that already has Google AdMob, which is Google's advertisement platform for apps, like in-app revenue advertisement to collect revenue. If you want to enable that, then if you want a boilerplate code for that, you would choose this. Same with maps. Same with now login. Login is a little different. It will automatically bootstrap the standard login fields like username and password, along with the password reset and maybe a forgot password option as well. And this the benefit is that this will follow the standard the material UI principles and Google's best practices for accessibility as well. So it is recommended that if you are building a login activity, if you're building any kind of login screen, you use this as a base. No, it is not necessary that you use this template specifically, but it is important that you understand what the template is doing and structure your project similarly to follow best practices. Then you have master detail flow. Master detail flow is when you have to view maybe like you have products on the left and you want to view a larger part of a more detailed view of the project of the product on the right. This is when you would use master detail flow. This works particularly well on tablets. Smartphones, it can become a little cluttered, so it might be recommended to condense it down a little bit and not show the product bar on the left. But for tablets, this works very well because you have the products on the left. You can select them, and it will show you a detailed view of the product on the right, maybe more details, a larger picture, more pictures on the right. Then we have navigation drawer activity, which is again, as the name implies, it creates a navigation drawer on the left. So you can swipe and it will open up the drawer. Then you have a settings activity, which you can use to configure your app settings, like internal settings. Scrolling is again the default. You can think of the YouTube app, the way it presents videos when you scroll down. It is called a recycler view. This is just a wrapper around a recycler view. And then same thing, tabbed activity, we went over this earlier. Fragment plus view model. This is if you are using the model view controller MVC architecture. This is the way, again, a template to help you do that. And finally, you have native C++. This ties into the NDK that I mentioned yesterday. I went over yesterday. NDK stands for Native Development Kit. So if you want your application to use C++ for whatever reason, maybe you want um, you want the application to be very fast. Maybe you're developing a game and you need the additional performance, or if you want to use an existing C or C++ library and not port it to Java or Kotlin, you can use native C++ to create bindings for those libraries, and that way you can run them directly on the phone without having to rewrite the code. You also have some other project templates for other platforms. So Wear OS is Android's Google's take on an OS for smartwatches. Again, the same. You have no activity, blank activity, which is a simple UI. Google Maps, which is more useful on watches, and then watch face if you want to create like a clock, like it emulates a digital or analog watch, a watch face activity. Same with Android TV. Android TV, you have a blank activity or no activity. Again, for background tasks, you choose no activity. For UI tasks, you choose blank activity. And then finally, you have automotive, which is Android Auto. You can have service and messaging service. Now Android Auto has a special category for messaging services, um, because they can interrupt the driver, so you have to take some additional precautions, but otherwise most of it works the same. So we will go with phone and tablet because it is the most common, and we'll choose basic activity just as an example. I'll click next, and you will notice that it automatically pre-fills some details. So the name here is my application. That is the default name. You can change it. Package name. Now, a package name, it must be unique in the Play Store. Every app must have a unique package name. Uh, Usually, if you are a company, if you have a website, you will reverse the website. So if you have xyz.com, your package name should start with com.xyz. This is because package names go from least specific to most specific. Think of it like going from all the domains, you choose the com domains, then you choose example.com, and then my application from example.com. So usually you would you if you have website, you the first part of your package name is the website's name, but in reverse. You put the domain name first and then the website name. And finally, my application. Maybe you want to develop more than one app for your uh, company, and then in that case you can differentiate by the last part. Save location is where you want it to be stored on disk. And language, it can be Kotlin or Java. Now Google is pushing Kotlin because of legal issues with Java, but and this is study jams with Kotlin, so we will be choosing Kotlin for now. Now, minimum SDK version is the minimum version that your app supports. So the newer versions of Android have a lot of new features. They sometimes have new APIs. They sometimes have new restrictions. So it is recommended to choose the lowest version that your app can run on comfortably. So and the Android Studio will also show you an approximation of what percentage of devices can run this, or at least can run this app. So for example, if you choose Jelly Bean, which is the lowest supported version as of now, you will see the 99.8%, that is nearly all the devices that run Android, will be able to run your app. Now I would not recommend using Jelly Bean because that has a lot of pitfalls. It is very difficult to work around those limitations unless your app is very, very simple, where it has a very, very simple task. I would suggest you choose something like API 23, which is Marshmallow, or API 24, which is Nougat. Both of them will give you a good amount of coverage. So Marshmallow gives you almost 85%, and Nougat gives you around 74% of coverage, or like 74% of devices that run Android can run your app, which is a good mix between, it's a good compromise between the portability, the compatibility, as well as the new features. So you do not have to develop with very, very old features of Android. Now, legacy Android would support libraries if you are developing on something like Jelly Bean or something. Um, then you would want to check this if you're using an existing code base. If you do not want to refactor the code base to fit existing standards, you can temporarily run the app by using those Android support libraries. Now, it is recommended that you do not because this is legacy code, eventually it will be deprecated and then removed. It is recommended that you do not use this very often. You try to migrate as soon as possible. But if that is not possible right now, you can temporarily run the app using these support libraries. Now, if you click on finish, the app will be created. Creating the app for the first time again it is a little resource intensive. You have to set up the build system, you have to set up all the app, all the folder structure. So it takes some time. That is why I have already created an app here. As I mentioned before, I already created this app prior to this meet and bootstrapped it. Bootstrap means I opened it at Android Studio and let it finish all the configuration processes. So when you open the app for the first time, if this is a newly created app that you have just made, um, let me see. I think yes. So if this is a newly created app that you have just made right now, it will you will see that there are two background tasks. One will be the Gradle sync task, which will sync it will download the dependencies, it will run the um, sources, it'll analyze the code, it'll open the appropriate files in the editor, and the second one will be the import task, which will just configure everything for you. So those will take some time to finish for the first time again, because Gradle has to download all the support libraries, and the yes. So this is the view that you should see when your project finishes importing. Um, this is I'll go over parts of this one by one. So this is the project files. It will show you all the files in your project. It is a tree explorer. You can see these SRC, which is all the source code of your project goes into SRC. Build is the um, build tools. So if you expand this, you will find it has generated intermediates. So this should not be tracked in your source code tracking system, your version control system. I'll go over version control systems in detail later on. You will notice that a git ignore is automatically created. It will automatically create this git ignore for you, so ready to be committed to source control. And hmm, yes, and the yes, so sorry, I was having connection issues. Um, so this is, as I was saying, this is the tree view. This is the tree explorer. It will show you all the files in the project. These are the editors, code editors. This is the main view model. Again, as per the model view controller system, this is the view model, and this is the main fragment of the app. Now, Android, the best practice is to split your code into fragments and activities. Um, that is beyond the scope of this session, so we will not go over that right now, but I would encourage you to check out the course on Google has some good code labs, Android code labs regarding this topic. um, the This is the main fragment. This is where this is what is started when the app is launched. Whenever the app launches, it will run. This is the entry point for the application. If you have worked with Java before, this is like the main function in a program. This is where everything starts. Um, And this is the on create view, and on activity created are special functions. Again, these are event functions that are triggered automatically by the system to tell your app, which state, which life stage it is on. I would All of these are very important concepts, but again, unfortunately, they are out of the scope of this session. I will share some code lab links at the end if someone is interested in going over. Now the first thing you want to do whenever you have a project is to build the project. To build an Android project, you in from Android Studio, you click on the Build tab and build bundle or APK. Now the difference between a bundle and an APK is that APK files are like exe files. You can run them directly on an Android phone. You can install them and they will work. Bundles are the newer way of distributing code. It is like packaging your code for one specific device. So when you create a bundle, it does not generate the APK right away. It simply takes your code, it will compile your code and your resources. Resources are all your image files, video files, assets, those you know, everything in the res folder are resources, and everything in the src folder right here. So everything in the src folder is code, executable code that will be compiled by the compiler, either the Java compiler or the Kotlin compiler. And res is all the resources that are needed, or the assets that are needed for your app to look good. So maybe you have video files, you can have image files, you can have icons. All of them go into the resources folder. So when you build an app bundle, instead of creating the APK file right away, it will simply bundle those resources and your compiled files into a bundle. And then when you upload the bundle to Google Play or a distribution service, the distribution service is responsible for generating and signing the APK. The benefit of bundles is that you do not have to deal with signing keys yourself. The distribution system will have to handle that, but and also the distribution system can strip out unnecessary parts. So if, for example, you might know that in Android there are several defined screen sizes. You have all the way from XDPI to XXDPI to triple XDPI, and all those resources are not needed for to run an app on one device. So let us say a device has XDPI. We do not need the other resources of SD or HD to run the app on that device. So if you use a bundle, then Google Play can strip out those resources, and this results in a smaller size, download size for the user, as well as it allows the app to start more quickly. Another benefit is that there's another feature in bundles called feature bundles. So feature bundles are separate parts of your code that might not be used by all users, but you still want to include them. For example, in Maps, in Google Maps, a feature bundle might be an optional Android Auto feature. Not everyone is going to use, maybe not everyone is going to use Android Auto with Google Maps, but for those who do, you can download that part. You can just download the files necessary to use Android Auto separately, and then that way, most of the majority of the users are not affected. The app size does not increase, but for the users who do need these files, the experience is improved. So going forward, all the apps on Google Play Store must be uploaded as bundles, not as APKs. But APKs files are still useful for debugging and testing. So that is why both are supported. For now, we will just click on build APKs. That you'll notice that there you'll have a notification called build APKs. It'll build it in the background. You can continue working on your app, on your code in the meanwhile. And once it is done, you will see there's a notification called build APKs. If you expand this notification, you will see that the APK has been built, and it is the location of the built APK. If you want to maybe copy it to your device or install it or send it to someone, it is in build, outputs, APK, debug, and app debug.apk. There's also this output metadata or JSON file, which will tell you It gives you details about the app itself, the build configuration, what was the timestamp, which compiler was used, which versions of resources were used, just for record purposes. And this is the final built app. Now you'll notice that there is another toolbar here, that is app and emulator. So this is a configuration. Again, build configurations are an advanced topic. Maybe you want to build maybe you want to build the app with debug information. Maybe you want to add debug logs to your app when you build, or you want to add some tests in your app when you build for debugging. You can All that can be controlled using configurations. And this is the emulator you want to run the app on. So as I mentioned yesterday, the built app does not need to be run on a physical device. You have the option of running it on a virtual device called an Android emulator, Android virtual device. And if you have multiple devices configured, you can choose one here. Now, if I click this button, if I click the Run App button, you will notice that it will rebuild the app, because just to be sure that nothing has changed. And once the build finishes, it will start the AVD. It will start the Android virtual device and build the app, run the built app on the virtual device. Now, this it might take some time, because the Android virtual device is quite a heavy app. It is quite a resource intensive process. So while this finishes, while this builds, I would like to take any questions. So we just went over how to create a project, the different kinds of projects, and how to build a project. If anyone has any questions or comments, I'll be happy to take them right now while this runs in the background. No? So if anyone would like to ask any questions either in the chat or by unmuting, I'll be happy to answer. Okay, so maybe you can also, if anyone has worked with this before, if anyone has built an app before, if you can share your experience with us?
Karthik, Karthik, are you there or is there any internet issue?
Okay. No, no, I am still there. I am
Yeah,
facing
yeah.
an
Now I can
emulator
hear.
issue.
Okay, yeah. Now you're audible.
Okay. Yes. So sorry about that. I had some system issues. So the emulator, if you build, if you run, if you press this button, the app should build and run on the emulator. Right now, I won't be able to show that because of some issues, technical issues. But that is what should happen. And the last part I would like to cover today is um, maybe going over the build system a little bit, the Gradle build system, and why you would want to use it as opposed to Android Studio. So first, let me exit out of Android Studio. Let me close the app, and let me open up the folder in Explorer. So um, right now, I'm sharing my screen. This is the folder. Um, so yes, so I hope you can see my screen right now. Yes. So this is the folder. This is in which the app is built. Um, this is the app folder contains all the source code and the resources both, whereas the build folder contains the build outputs. We went over this earlier. Now you will notice that there are two files here, gradlew and gradlew.bat. Um, Now, Gradle is the build system that is the most popular for you for building Android projects. You can use other build systems, other Java-based build systems like Maven or Ant, but Gradle is the most popular. Um, and most Android projects that you find will be using Gradle. Now, the benefit of having such standardization is that Gradle is very optimized for the Android build process. There are a lot of custom extensions, a lot of plugins, and a lot of libraries that Gradle can deal with automatically. Gradle will automatically download all the libraries that you need for your app and package them with the app so that you don't have to worry about it. The Android Studio can trigger Gradle, can work with Gradle directly from the GUI, but we can also do that directly from the command line. So right now I'm navigating to the folder in the command line. This is if I just list out the folders, you can see this is the same folder. And to trigger a build, to build the app from the command line, you type in Gradle W. Gradle W. W stands for wrapper. This is just a wrapper around the actual Gradle command to run it from the command line. Android Studio directly interacts with Gradle from the internal system calls, but for the command, if you want to run it from the command line, it is better to use the wrapper because it will deal with all the environment variables necessary. So Gradle W space dash dash help. So this will print out the help information. So whenever you work with an unfamiliar command, whenever you work with a new command, it is better to read the help information once. So um, yes, sorry about that. So as you can see, the help information will print out all the options, all the available options, as well as the description. Um, To build an app, you simply type in gradlew and then assemble, debug. Now, Gradle commands are usually split into multiple categories. So the assemble if the prefix indicates that the command is going to build an output. It is going to build a debug APK, build an APK, and debug is the name of the configuration it will use. So that it will use a debug configuration, which means it will not obfuscate, it will not remove the debugging information from the code. It will keep class names, it will keep variables names, which is helpful for debugging. So you run gradle w assemble debug. This will build the app. Since the app is already built, I will not run this right now. You can also run assemble release, which will build a release version of the app. Now, to build a release version of the application to distribute on other Play stores, on other alternative stores, maybe like Aptoid or Updown. These are alternative app stores to the Google Play. So if you want to distribute on them, you will need to generate a release APK. To do this, you will have to generate signing keys. Now, again, signing keys are a little out of the scope of this session, but Google has some excellent tutorials on how to generate these signing keys and how to use them to sign a version of the application. For now, if you try to run assembly release, Gradle will complain, it will error out, it will complain that the signing keys are not set up right now. You will notice that Gradle will start a daemon. A daemon is a background process that runs to facilitate the build process. Now, you might ask, why are we doing this? Why are we using the command line where we can do this very easily through the GUI? Now, again, using the command line is sometimes faster because Android Studio is a large program. It takes some time to start. So it might be easier to do a quick build from the command line. But the real power, the real benefit of using the command line is automation, system integration. So let us say you have an automatic build system. Let us say you want to automatically build your app every 2 weeks and publish to the Play Store. It is very difficult to set up that from the GUI, but you can do that very easily from the command line. You can write a script. You can have a script, automated script to check out the code every 2 weeks and build the APK, sign it with your signing keys, and then publish to the Play Store. Now, the again, Google has some excellent collabs that explain about Gradle in more detail. But one more thing I would like to just mention is that this is very useful in CI/CD as well. CI/CD stands for continuous integration and continuous deployment. It is a code management system where you build your code. Whenever you save your changes, whenever you commit your changes, you build and test your code to ensure that it is working properly. That way you won't suddenly 2 months in you find that your code doesn't compile because of a simple bug or something. So those bugs are easy to catch when they happen, but later on it might be difficult to pinpoint exactly where is the bug. So CI/CD systems help you avoid this. If you are using any kind of CI/CD system, then it will most likely be through the command line and not the GUI. So in that case, you will need to use Gradle from the command line. So it is beneficial to know how to do that. You will see it will it will download all sorts of things. It will Gradle will automatically handle the libraries necessary to build the project. So since we do not want to build the project right now, I haven't set up the signing keys. I will go ahead and cancel the build, and I will stop sharing my screen. So that will be all for today. Thank you for attending the session. If you have any questions about any part of the session, I would be happy to take them right now. So if you have any comments, if you have any suggestions, if you want to ask me something regarding Android, regarding maybe my other sessions, please feel free to do so now, either in the chat or by unmuting. We will be having one more session after this. So So if there are any questions, I will take them right now. Otherwise, we can end the session today for today.
I don't think we have any questions. So thank you everyone for joining, and do stay tuned with us. Do follow us on Instagram and join our Zulip server, and stay tuned with us. Thank you.